In this lesson, we're going to learn about alkanes, alkenes, and alkynes. So we talked about organic chemistry being the study of different carbon-containing compounds. So we're going to look at the most basic backbone of these compounds, which is made up of carbons. And then in future lessons, we will look at different functional groups that can be added on or part of these molecules. So we'll start with alkanes. So the backbone or the main chain of an organic compound is composed of carbon atoms. And as we look at alkanes, we are only going to look at right now the carbon backbone and then hydrogen atoms that are attached to that. So carbon has 4 valence electrons, and so it is going to need 4 different atoms that it bonds to end up being stable. So every single carbon is going to have 4 bonds. So we're going to have bonded to however many other carbon atoms, and then every single carbon is going to get filled up with hydrogens to make the rest of those bonds. So here this carbon has 1 bond to another carbon, so it needs 3 more bonds. So we have 1, 2, 3 hydrogen atoms. So alkanes here are molecules that have all single bonds. So with all of our carbon backbones here, there are no double or triple bonds, only single bonds. So when we have 1 carbon, there are no other carbons, so we have 4 hydrogens there. 2 carbons, we have 1 other carbon that is bonded to, and so 1, 2, 3 hydrogens. And then here we have 3 carbons, so we've got 3 hydrogens here, 2 here, and 3 here. So what we're going to see is, with the exception of methane, which has 4 hydrogens, every single carbon that is at the end is bonded to only 1 other carbon, and so it is going to have 3 hydrogens attached to it. And any central carbon that is not on the end is attached to 2 other carbon atoms, and so it only needs 2 more bonds. So there will be 2 hydrogens attached to any of the central carbons. So for alkanes, our general formula for the molecular formula is CnH2n plus 2. So the N here represents how many carbon atoms there are. So if I have 5 carbon atoms, I'm going to double that, 10, and then add 2. So C5H12. So the reason this happens is that every single carbon has 2 hydrogens that are going to be attached to it. And then the plus 2 is on either end. So the 2 carbons on either end are going to need a 3rd carbon attached there. So for every single alkane, we can give a molecular formula which tells us how many carbons and how many hydrogens there are. And then we can also show structural formulas. So there's the expanded, which shows every single atom and every single bond. And the condensed only shows the bonds between the different carbons and shows the hydrogens that are attached to a carbon in one spot. So how many hydrogens are attached to that particular carbon, as opposed to drawing every single one of those out separately. In terms of naming, we have prefixes depending on how many carbons are in that backbone. So if we have 5 carbons, 1, 2, 3, 4, 5, then the prefix there is going to be pent. Because all of these are single bonds, we have the ending ane. So alkanes get the ending ane added to them, and that just tells us all single bonds. And then the prefixes here will tell us how many carbons there are in that backbone. And then hydrogens, we are just going to double our carbons and add 2. Or if we were drawing out the structural formula, we could count, so adding in enough hydrogens that every single carbon has 4 bonds total. So if we look at methane here, methane is 1 carbon, so meth is the prefix for 1 carbon. And because there are no other carbons here, need 4 bonds, so there are going to be 4 hydrogens here. And then the ane just means no double bonds. So because this carbon is only attached to hydrogens, there can't be any double bonds because hydrogen can only have 1 bond. So this is what we would see if we were to build this with the molecular model kits. And this helps us to see a 3D representation, and it shows us the bonds, but in reality, there's not actually going to be sort of a line where the 2 electrons are in between 2 different atoms. So this visual representation is a little bit closer to what would be seen, but this just allows us to see whether we have single, double, or triple bonds. So different visual representations there. This is the expanded structural formula, which gives us all atoms and all bonds. And then this we'll look at in more depth in another unit on atomic structure. And this is just a way that we can draw and show the 3D shape of a compound on paper or something flat in 2D. So this is what's called a tetrahedral shape, and like I said, we'll look at that later on in another unit. So this is ethane. Eth is the prefix for 2 carbons and then all single bonds, so ane. Molecular formula is C2H6, so if we double the 2, that's 4, plus the 2 for our ending hydrogens gives us 6. So there's our 3D, what that's going to look like, and then different visual representations there. The expanded structural formula. And then the condensed formula, so we talked about this earlier, that this shows how many hydrogens are attached to a carbon without drawing each one out separately, like in the expanded structural formula. Line angle formula, so we've looked at this before too. So this is sort of the quickest way that we can draw our structures. So every single point in our zigzag here represents a carbon atom. If we have any other types of atoms, so we're not going to see those in this lesson, but if there are any other types of atoms, those would have to be shown. So for example, if over here there was an oxygen instead of a carbon, then I would have to show that it's an oxygen and not a carbon. So otherwise the assumption is everything there is carbon. And then the part that's not shown is hydrogens, and so the assumption is always every single atom that is in there is filled up with hydrogens to end up with the correct number of bonds. So carbons can have 4 bonds, and so any carbon needs to have 4 bonds total. So over here, this is bonded to 1 thing, so it needs 3 hydrogens. This carbon is bonded to 2 things, so it's going to need 2, and so on. Oxygen can have 2 bonds, so here that already has 2 things it's bonded to, so that wouldn't have any hydrogens. But adding in hydrogens is going to be true for any other atom as well. That's the one thing that we don't show on here. Okay, alkenes and alkynes. So alkanes, which we just looked at, are saturated compounds, and that just means that they have the maximum number of hydrogen atoms attached to every carbon atom. So we couldn't possibly break any bonds and add any more hydrogens in there. Alkenes and alkynes, on the other hand, are unsaturated, and it's because they have multiple bonds. So they may have a double or a triple bond between a couple of the carbons, and that means that there will be less hydrogen atoms attached to those carbons. So alkenes are when we have a double bond, and the general formula for those is CnH2n, and alkynes are compounds that have a triple bond in them somewhere. And CnH2n minus 2 is the general formula for those. So in terms of naming, the prefixes are the same as for an alkane, and then at the end, if there is a double bond, then we are going to add -ene as the ending, And if there's a triple bond, then we're going to add -ine or YNE as the ending. So this just shows us for 2 carbons as an alkane, so single bond, double bond for an alkene, and triple bond for an alkyne. And we can see as we move along, as we increase the bonds between the carbon, then we're going to decrease how many hydrogens are attached to it. And so here, as we add even another bond, then we have one less bond on each carbon that can be made with a hydrogen. And then examples here for prop or 3 carbons, so propane, all single bonds. Propene, we have a double bond in here, and propyne, we have a triple bond. Okay, let's look at a couple of examples here. So we have 1, 2, 3, 4 carbons here, 1, 2, 3, 4 carbons here, and both have a double bond in there. So both of these, bute is the prefix for 4, and ene tells us there is a double bond. But these two compounds are not the same because their double bond is not in the same position. So we need a way to help us name these to show that they are different. And so what we do is we number the carbons and then say which carbon that double bond is off of. So if I number these carbons 1, 2, 3, 4, the double bond is in between carbons 1 and 2. Whereas in this question, the double bond is in between carbons 2 and 3. So when we look at the 2 carbons that the double bond is between, we're going to use the lower number. So we're going to say that this double bond is off the first carbon, and this double bond is off of the second carbon. So we're going to use that in the naming, and then the number comes before the part that tells us it's a double bond. So the ene is what tells us that we have a double bond. So we're actually going to split the name apart here, and at that point we are going to input a 1 for this one and a 2 for this one for the naming. So we have bute 1 ene and bute 2 ene. And you may see in older articles or textbooks, this number used to actually come on the outside. So 1 butene and 2 butene. The naming system has been changed around so that the number goes right before the part that actually tells us where the double bond is. So if you see that, that's just because this is the updated naming system. So the other thing is when we are going in between words and numbers, we use dashes. And then in a moment, we'll see when we have multiple numbers. So this next question, if you want to pause the video and try this one first to see if you can get that, and then come back and play to see how you did. So we're going to number these carbons again. And as I number this, the triple bond here is between carbons 3 and 4. So going based on what we had said before, so 5 carbons is pent, and then between 3 and 4, we're going to use 3 because it's the lower number. However, if I were to flip this around, so if I had this molecule built and I just turned it, then this would be my numbering. And so that puts the triple bond between carbons 2 and 3. And so what we're going to do is we're always going to number the carbons from the direction that gives us the lowest possible number. So in this case, that is not the correct numbering. So we're going to start from the right side, and that puts the triple bond off the second carbon between the second and the third. And so that is going to be pent 2 for off the second carbon, and then ine because it's a triple bond. And there we go. Pent 2 ine. Okay, so here we have once again 4 carbons. So carbons 1, 2, 3, and 4. So that is going to be bute for 4 carbons. And then we have 2 double bonds, not just 1. And in this case, whether we number 1, 2, 3, 4 or 1, 2, 3, 4, in both cases, carbons 1 and 3 are what the double bonds are off of. So the first one off carbon 1, so between carbon 1 and 2, and the second one off carbon 3, or between carbon 3 and 4. So for the double bond, the ene, I'm actually going to use a prefix there to tell me how many double bonds there are. So di is the prefix I'm going to use to tell me that there are 2 double bonds, so di-ene, and they're off the first and the third carbons. So this is bute 1, 3, di-ene. So I've got dashes in between the word and number parts, and then a comma separating my numbers. And what you'll notice is the number of numbers I have here matches my prefix here.